Hi, welcome to the College Algebra Exam 2 Part 2 review video. This will be covering problems 18 through 26. So, number 18 says, use the graph to solve the equations and inequalities. Write the solutions to the inequalities in interval notation. Okay, so part A says that 2x plus 1 is equal to negative x plus 4. So we have those two lines here, and we can see that they intersect here. So we know that x is equal, for A, x is equal to 1. For the next one, we have 2x plus 1 is less than negative x plus 4. So we know that this red line is the second equation. So we know that that's the bigger equation. So that one's on top. And we know that the blue equation is less than. So we know that we should be on this here, because the y value of the red line is greater than the blue line at 1. So we have, for this one, for B, x is less than 1. And we have the exact opposite for the other one. On this side of the graph, the blue line is bigger. The y value of the blue line is bigger than the red line. So that means that x is greater than 1. And if we want to put those in interval notation, that's going to be 1 to infinity. Oops, no, this is backwards. Oh, that was backwards. This one is negative infinity to 1. And this will be a bracket. All right. Number 19. Write an equation of the line in slope-intercept form that passes through the points 2, negative 5, and 3, or in 7, negative 3. So, what we need here in this equation is m and b. And so we know we have an equation for m, and is equal to y2 minus y1 over x2 minus x1, which in this case will be negative 3 minus negative 5 over 7 minus 2, which that is equal to 2 over 5. So that is our m. So if we put it in our slope-intercept form, we have y equals plus b. And then we can plug in a point and solve. So we know that negative 5 is y, and x is 2. So we can we know that b is equal to negative 29 over 5. So our full equation is y equals 2 over 5, 2 over 5 x minus 29 over 5. All right, for question 20, write an equation of the line in slope-intercept form that passes through the point negative 7, 3 and is parallel to the line defined by x plus 3y equals 6. So first we have to figure out what the slope of this first line is. So we are going to take 3y, negative x plus 6 is equal to negative 1/3 plus 2. So we know that this is the slope, and if it's parallel, it has the same slope. So we can write that out. Y equals negative 3x, or negative 1/3 x plus, and we need to find this b. And we do that by plugging in our point. So 3 is equal to negative 1/3 times negative 7 plus b. And so that means we have 3 is equal to 3 plus b. And so b is equal to 2/3. So y is equal to negative 1/3 x plus 2/3. Write an equation of the line and slope intercept form that passes through the point -8, -4 and is perpendicular to the line. Right. So now we do the same thing. We find out what our first equation is. Right, and so when we know that when a line is perpendicular to another, the slopes are negative and they're reciprocal. So that means the slope of this line is going to be -6. So, so we have our equation. And we have to find that b, and we do that by using our point. So -6 times 8 plus b is those equal to -4. So we have -4 is equal to 48 plus b, so b is equal to -52. So we have y is equal to -6x minus 52. All right, given the basic function x squared, use transformations to graph x minus 2 squared plus 3. So, what's the transformations in the order that they are applied? So, first we are going to start with the inside. So we have an x squared here, and the whole thing now being squared is x minus 2. And that means inside of this, we have this -2, which means we're moving the graph to the right too. So transformations is shift right 2. So put this in red, we'll be here, and here, and here, and then 1, 2, 3, 4 here. So this graph then looks like this. And then our other translation is we have this +3. That means we're going to shift upwards 3. So the answer, which is going to be our green one, is going to be this graph right here. And so this graph is going to be x minus 2 squared, and then this green graph is going to be our answer, which is going to be x minus 2 squared plus 3. Question 23 says a speeding ticket is $100 plus $5 for 1 mile over the speed limit. Write a linear function to model the cost of the speeding ticket for the individual traveling x miles over the speed limit. So, we know that our y is going to be s, and we know that this is going to be a linear equation because for every 1 mile we go up $5, and that's going to be consistent for every one. So we have s is equal to mx b, right? And so the m is going to be the slope, the amount of money it goes over for every mile per hour, which is going to be 5, and b is going to be our starting value. So if we're going 0 miles over the speed limit, we're going to pay $100. So that means that part A is going to be S is equal to $5 times X plus $100. Then we just simply put in 15. So S, here, let me write it like this, S of X, and then S of 15 is equal to 5 times 15 going to be equal to $75 plus $100 equal to $175. All right. Question 24. The data given in the table represents the age and the blood pressure for 12 randomly selected individuals. Using the regression features in your calculator, find the least squares regression line. Round A to 3 and B to the here's. So, in order to do this problem, we're going to go back up to our table. We're going to pull out our calculator, and we're going to go to stat, the stat button, and we're going to go to edit, and we're going to go to the first button, and we're going to put in all of our numbers in the table. So age is going to be our X's or our L2s, and our blood pressure, or BP, is going to be our Y or our L2. L2. Hold on. So our X's are is the L1 column, Y is L2 column. And once we do that, we go back to stat. We're going to go over 1 to calc, and we're going to press 4. It's called lin reg, AX plus B. And we're going to click enter, and it should give us our A, B, R squared, and R. And for this, I get 0.511, and the B, I get 104. The R squared, I get 0.9242, and for the R, I get 0.9613. So, for part A, this is the answers. Those are our A's and B's. And for B, this is our correlation coefficient. I'm not sure what a good regression line would be. That is up to you in your notes, because I do not have those available to me. So it is up to you to determine on your own if that is a good fit for the data. But, however, we can go on to part C, and we can approximate the blood pressure for a 55-year-old. So if we have Y equals AX plus B, Y is equal to 0.155 times that 55 years old, plus the 104. And we should get 132, which we can check back up here at our table. It should be around that range right here, about in the middle. For question 25, identify the following basic functions from their graph. So, for this one, I can see that we have two points pointing upward, up here and up here, so I know it's an even polynomial. And we have 1, 1 and 2, 4, so I know that this is a quadratic. This one, we have one going up and one going down, so I know it's an odd quadratic. And I know that a quadratic is going to be x cubed. This one, we have an asymptote here, an asymptote here, and so I know that is 1 over x. For this one, we have a line that looks like this. We have 1, 1, and we have 4, 2, which is the opposite of this one up here. So I know this one's the square root function. And this one we have the square root looking function, but with 2 tails. So we know it kind of looks like this one. So we know this one is the cube root, or x to the third. And this one we have the v shape, so we know this is the absolute value of x. Question 26. Given the base function y equals the absolute value of x, use the transformations of the graph to do f of x equals negative absolute value of x plus 3. List the transformations in order. So we are first going to start with the inside of the graph of our function. Since we have an absolute value function, we look inside the absolute values and we get x plus 3. We know x plus 3 means that we are shifting the graph to the left 3. So I'm going to pull out my red. We're now going to have our vertex here, and we're going to go up each of these points this way and that way. So this is x plus 3. And then we apply everything on the outside, and that's going to be this negative sign. We don't have anything else. So that means we're going to flip the graph. So we're going to flip the graph over the x-axis. So since we're at 0, 0 here, that stays, but now we are going downwards. So there's that, and there's that. So this one is now negative f